Assalamualaikum and hi. Is it just me? Or the environment is getting hotter these days that I sweat buckets after only taking a few minutes walk outside of my house?
Well, that may be the case, as there is no doubt that the increasingly worldwide problem regarding waste heat and environmental issues has been highlighted heavily recently. So, you will probably be wondering, where does some of this waste heat come from anyway? The answer for that is it comes from the exhaust of conventional burner operation. For your information, in conventional burner system, not all heat supplied will be converted into useful mechanical work. According to the Department of Energy, small home boiler efficiency is only at about 55 to 75%. As such, the temperature of the chimney can exceed 103 degrees Celsius, which is pretty hot.
You will probably wondering what is the best way to reduce or even to stop littering waste heat. One of the possible methods to recover the waste heat from the industrial burner is through the implementation of exhaust gas recirculation. How does this thing work actually? Well, exhaust gas recirculation is traditionally used in internal combustion engine for reducing the nitrogen oxide formation. The system works by recirculating the exhaust gas back to the point where the combustion takes place. Nevertheless, EGR does not only reduce the nitrogen oxide formation, but also it can be used to heat up the oil without the use of external energy by integrating the fuel preheating system into the exhaust gas recirculation system. So, how does the fuel preheating system affect the burner operation performances? Well, preheating the fuel before it enters the combustion chamber will increase the temperature of the fuel and reduce the fuel kinematic viscosity. Viscosity is basically the thickness of the fluid. The lower the viscosity, the less thick the fluid will be and the easier and smoother it will flow. Reducing the kinematic viscosity of the fuel will improve atomization. For atomization, it can be visualized as somewhat similar with the application for the water spray. It is the process whereby bulk big-sized liquid is transformed into a collection of drops. As the atomization improves, the surface area of the fuel droplet will be larger as its size has decreased, which makes it easier for the fuel droplet to mix and collide more effectively with air particle as it enters the combustion chamber. Thus, this will improve combustion. Therefore, less power will be required for the combustion to take place. So, in my final year project, I will address the challenges of designing an innovative EGR system integrated with fuel preheating system that will decrease power consumption requirement. Therefore, in order to achieve that, the first milestone that I need to conquer is to find and apply the best concept for the fuel preheating design implementation. There is always more than one way to skin a cat, and I believe that there are lots of concepts can be tested, as there are a long list of variables to be considered that can affect the efficiency of fuel preheating mechanisms, such as the thickness of the fuel tank, radius of the storage, heat transfer method, etc. etc. Then the next thing is to select the right materials for the fuel preheating system. Every material has different properties and ways to be utilized. Therefore, in this research, multiple materials are compared to check its compatibility in the EGR operation. Last but not least, another vital thing is to simulate the design of fuel preheating system using computational software. I mean, how can we evaluate the system performances if we don't simulate it? Finally, we can optimize the final design. To sum up, I truly believe that the production of excessive heat from the conventional burner can be tackled with the design of a novel EGR system integrated with fuel preheating system for industrial burner application.
With that, ladies and gentlemen, thank you for your kind attention.